In the last lecture, we have seen the stepping stone method. Via that, we have moved towards the next, means we have done one iteration and moved towards the optimal solution I have said. But again, we are supposed to check that solution is optimal or not. So today in this lecture we will see that how that the new solution where we have reached is the optimal or not. Okay. So I am continuing at the stage where we have reached in the last lecture. So here is the situation where we have reached in the last lecture. First of all, before doing that, all I want to do is in this stage, means this was the solution via the Vogel's approximation method. Let me first calculate the transportation cost related to this. Okay, so you can identify that actually this transportation cost is changed via the stepping stone method. So the transportation cost from this point it is 4 times 3 plus 2 times 4 plus 6 times 1 plus 3 times 3 plus 1 times 9 plus 4 times 4 plus 1 times 8. Okay, we were having 3 plus 4. So here we are having also 3 plus 4 answers. So that is 4 times 3, it is 12 plus 8 plus 6 plus 9 plus 9 plus 16 plus 8. Here it is 30 plus 15 plus 25 plus 8. This is 40 plus 30, so it is 78. Okay, so previously this solution was 78. Now, after applying the stepping stone method, where we have reached that I want to explain. See, after applying stepping stone method, the transportation cost is 4 times 3 plus 1 times 4 plus 1 times 2 plus 6 times 1 plus 3 times 3 plus 2 times 9 plus 4 times 4. Okay, so 4 times 3 it is 12 plus 1 times 4 it is 4 plus 2 times 1 it is 2 plus 6 times 1 it is 6 plus 3 times 3 it is 9 plus 2 times 9 it is 18 plus 60. So here we are having 10 plus 14, so it is 24 plus 27 plus 16, so it is 40 plus is 67. So previously the answer was 78, and now it should be one difference. Okay, sorry, somewhere I have made a mistake. Oh, sorry, it is 77. 2 plus 2 7 plus 6 plus 4, so it's 1, it is 67, it is okay. 12 plus 8, 12 plus 8, So it is 24. So to this it is 24. This is 27 plus 16. It is 67. Okay, anyhow, but we have reduced in the transportation cost. It must be 1 unit difference. Okay, somewhere I have made mistake. Let me calculate it here. 4 times 3 it is 12, 2 it is 8, here it is 6, here it is 9, here it is 9, then 16 and 8. So sum is 20, here it is 20, sorry. Okay, so that is why here it is 68, and now it is 1 unit deferred, as we have seen that actually it will defer by 1 unit because in this we have transported 1 unit extra, and the corresponding the transportation cost was reduced by 1 unit that was given. Okay, so that's 1 unit is reduced by this method. Now all we have to check is that this solution is optimal or not. That is very interesting thing. Means can we further reduce the transportation cost or not? That we have to check. So for that, I have pasted it again, and again we will apply the stepping stone method. Okay, so for A to 1, again we will check. So if I am transporting from this point, then I have to add 1 here, then I have to subtract 1 here, then I have to add 1 unit here, then I have to subtract 1 unit here, then I have to add 1 unit here and subtract 1 unit here. So our loop is like this. In that case, the cost is 1 times 2, that is 2, minus 1 times 3, it is minus 1, minus 1 times 2, it is plus 2, minus 1 times 4, so it is minus 4, minus plus 1 times 9, so it is plus 9, then minus 1 times 3, it is minus 3, and we are reached to the original situation. Okay, so this sum is this is 2 plus 2, 4, so it is minus 4, so this is cancelled. Here this thing will be cancelled to the 6. So sum is 6. So additional cost, additional transportation cost is 6. If we will transport 1 unit from here to what? Okay, now if I will transport from A to 2, then what is happening? That I want to check. So in that case, I am adding 1 unit here. Or now I just write in the direct method. Okay, so from here I am going towards here, then here, here, and here. So here I am having addition, here I am subtraction, I am having addition and subtraction. So corresponding the transportation cost is additional transportation cost on A to 2 is 11, then here it is minus 3, then here it is plus 2, then here it is minus 4. So here it is minus 2, minus 5, so it is 6. So that is not preferable. Similarly, for transporting from A to 3, what is happening? Let's check again. So for A to 3, the additional transportation cost is, from here I want to make a loop. So of course I have to go here and then go here, then come here. Then I have to come here, then here, and I can come back here. Okay, so this cell will be positive, this cell will be negative with minus 1, here it will be positive plus 1, minus 1, plus 1, and minus 1. So negative corners, just I have to write this. So here it is plus 3, minus 2, plus 4, minus 9, plus 4, minus 10. 3, minus 2, 4, minus 9, 4, minus 10. So here sum is 3 minus 2 it is 1, 1 plus 4 it is 5, 5 minus 9 it is minus. Oh, sorry. I have made a mistake in the calculation, this sign. Okay. What is the mistake? here I have to go for the positives and here I have to go for the negatives. So this is the mistake. So at this one I am having addition, here subtraction, addition, subtraction, addition and subtraction. So here it is plus 10 minus 3 plus 2 minus 4 plus 9 minus 4. Okay, so here it is plus 10 minus 3, so 7 plus 2, so 9 minus 4, so it is 5. 5 plus 5, so it is 10. So here again I am getting the additional transportation cost, so we cannot default to transport from A to 3. Now let transport from A to 5 and then check. So if I am transferring from A to 5, here is a loop. So here we will add something, subtract, add and subtract. So the transportation, additional transportation cost is doing that is plus 7 minus 1 plus 2 and minus 3. So that transportation cost is 6 minus 1, so it is 5. So again we cannot defer to transport from A to 5. Let transport from B to 1. So B to 1. So transportation cost is if again we have to make a loop first of all. So from here we are starting. So that is here is the loop. From this non-allocated cell, I am going to the allocated cells and at wherever in which allocated cell I am going, I am changing the direction. So here we will have plus, here we will minus, plus, minus. So the additional transportation cost on transferring from B to 1 is here it is plus 1, here it is minus 4, here it is plus 9, here it is minus 3. So the sum is minus 3 plus 9 is 3. Okay. So transferring from B to 1 is again not treatable. So better to go for another. But again, here we can transfer from this point also, B to 3 also. So let me make a loop. So this is a loop from negative, from non-allocated cell we have moved to the allocated cells, and wherever we reach we have changed the direction. So here we will have plus, here we will have minus, plus and minus. So the additional transportation cost on doing that I am having plus 7 minus 4 plus 9 minus 4. So it is 8. So transferring from B to 3 is also not replayable. Then check for C to 4. Okay, C to 4 is transportation is possible, means gives a reduction in transportation cost or not. Okay, so C to 4, if transferring we are from here, then the loop we can have either from here. So yes, this from non-allocated cell we are related to the allocated cell, again and new allocated cell and come back. So here we are having plus sign, here we are having minus sign, plus and minus. So the additional transportation cost on transporting from C to 4 is here we are having plus sign, so it is 8 minus 2 plus 4 minus 9. So 8 minus 9 is minus 1, minus 3 and so 4, so it is 1. Okay, so additional transportation cost for transporting from C to 4 is 1, so that is also not replayable. We are left with the last cell that is transporting from C to 5 is the one that we have to check. So let me check that. So if we are transporting from this point, that means C to 4, so C to 5, in that case, from this, the only elevated cell in this direction is this. From that, we can go here, this elevated cell, from there here, and we come back. So here we are having plus sign, here we are having minus, then plus and minus. So additional transportation cost on transporting in this direction is, here we are having plus 12 minus 1 plus 4 minus 9. So that is 11 plus 4, that is 15 minus 9, so it is 6. So additional, so in wherever it is not allocated, if we are planning to allocate transport from any of these non-allocated cell, then we have to pay extra. Means this is our optimal solution. So this is our optimal solution, and the corresponding transportation cost is, as we have already calculated, that is 67. Okay, so you try some more problems similar to this at your home, and then you will see that how actually we are reaching towards the optimal solution via stepping stone method. In the next lecture, we will see a few more problems via one more problem via stepping stone method. We will read to the optimal solution via the stepping stone method, and we will see in this you may have seen that you have to reach to the optimal solution. We have to calculate too many these loops and corresponding values. Okay, so that is a difficult task comparatively. So, how to directly evaluate this additional transportation cost without making this type of loops? That will be in the next coming lecture, that is Modi method. In that, we will directly identify the 6 without calculating, means finding this loop and calculating the sum and differences and anything. Okay. So till that you try one more problem at least by your own. Write down one more problem similarly and solve it by your own. Okay. So thank you. Stay at home and stay safe.